guys, I'm Pam Fisher, and as was said, I work with Walmart. Thank you. Jeff will be up here. Well, here he is. Awesome. So we work in the customer technology area, so to think about that, it's almost anything that you see in the store that you as a customer interact with. It's some pretty cool technology. So I've been with Walmart for almost 19 years, and every day it's something new and it's something fun. So with that, I'm going to let Jeff introduce himself, and then we'll get started.
Hi, am I on? Am I good? Okay. My name is Jeff Parker, and also work with the customer technology area within Walmart, focusing on point of sale. And we're going to take you through a little bit of what we're looking at, what we do from day to day, and some of the R&D that we're doing today on some of our next generation point of sale systems that we're building for Walmart, and some of the challenges that we're facing, and let's just see what we look like on the inside a little bit. And a disclaimer, real quick, is the opinions that we're posing today are not Walmart's, and any products that we reference, we're not endorsing any of those. So let's get started, Pam.
Awesome. How many of you guys wondered when we said a hostile environment what the heck that was? So a hostile environment
I thought you were talking about me.
Well, Jeff, I do know you don't know a lot about this, so anyway, a hostile environment is any environment that you're operating in where you don't have enough resources, you don't have enough network, and anything and everything could happen that would blow up your services. It's pretty simple.
Yeah, Pam, so we've been, at Walmart, we have been in the kind of computing industry for about 40 years. And a lot of our stores, we only do upgrades about every 5 years. So a lot of times the hardware that we're running into as we're going out and deploying is not the most recent. Some of the versions of software that we may be operating with, sometimes they don't always get updated. So there's a lot of challenges that we run into that we are looking at and trying to figure out how we're going to go solve some of those. It's really similar, Pam, to, whoops, I went the wrong way, kind of the autonomous vehicle industry that's out there today. We kind of looked at it and we said, this is very similar. They have there's a lot of challenges. You can think about, you've seen some, I'm going to move this down. Challenges out there today with like how do you provision and update software in an environment that's kind of moving around. But also, you know, autonomous vehicles are very new right now. So it's actually a pretty simple problem for them to go solve. There's not very many of those vehicles out there. There's also, it's all very new recent hardware, but think about in 10 years, if you had a vehicle that could drive itself, 10 years from now, you may still have it. What kind of hardware is running on that? What kind of software updates are going to try to be pushed out to it? Think about your cell phone. How long do you keep a cell phone? Anybody got a 10-year-old cell phone? No, yeah, most of them are gone in a couple of years. So we cycle those very quickly, but vehicles are much more expensive, and so is compute hardware. So those challenges are going to be facing you know, all of us at some point in the future.
So our stores are much like the autonomous vehicle. We've got a lot of cases out there where there's unknowns, and we have to be able to react very quickly to situations that happen in the store. So some of that is network availability. So do I have the network to be able to get communications down to the store and then back up from the store as well? And how do I deal, like we said before on the hardware, there's 2.1 million different combinations of point of sale hardware that I could have in any of my stores right now. That's a boggling number if you think about that.
So what are we as a point of sale team, what are we trying to go do? Our goal is to provide a seamless, consistent customer checkout experience. And that's, it sounds, you know, it might be kind of easy. You think about that, and, you know, we push a lot of software down to our stores today. And if you've ever been through one of our stores, it's usually a pretty good experience, depending on when you go and what's going on. But we also are pushing forward into new experiences in the checkout. You might have heard of Scan and Go. Definitely self-checkout. Everybody's probably used one of those. We have a lot of different ways that we're starting to allow customers to purchase things in our stores. And it's changing. And the software that we run today doesn't quite model out where we want to be. So we are definitely building out new cloud-based, service-oriented architecture that can handle all of these different types of devices simultaneously. So the challenges that we identified that we're going to come up with was today we have cloud-native services that are running in the cloud, and we do run some of our early version Scan and Go type applications on mobile devices. Actually run right out of the cloud. However, if you're on AT&T and they're having a bad day, or your phone's not working, you can't use that. So that's a poor experience. Now you've got to revert back to something different. The next thing is the data location. Whenever you're building services and you're moving things around in the cloud, the proximity to data is actually very important, especially when you think of if you're taking that bottle of water and you're going to scan it, and how long do you want to wait before it rings up the price and tells you what it was and the taxes and how all that works. A slow customer experience is a really bad one. So we want to make sure that we have data very close to the services that we're running and deployments.
Right, so we have to figure out how we're going to deploy to 6,000 US locations and be able to do it without any downtime that's going to affect the customer. So Jeff, why don't you tell us about the cloud native services?
Well, today we run a set of services in the cloud, and they are talking to data providers in the cloud. And that works out really well. Cloud to cloud is very reliable. We have lots of compute available. We can do pretty much whatever we want to go do. But as we kind of move to a store environment, we want to move that capability over to the store. We want to make sure that as soon as, if something happens, for example, if my network goes offline for any reason, that I can continue to function. And that's going to be important to us. We also really do not want to have multiple versions of our checkout services running out between a store and a cloud. It's really difficult to try to manage that. Where's the data, how those things operate. So those are kind of our constraints, the challenges that we're looking at from a services perspective. So what's that kind of look like? To be able to run things in our stores in a cloud-like environment, we still need isolation of the services. So we want to be able to deploy a service without affecting the other services that are running there. We also need to have multiple instances of some of our services running, and that's from a, it's not huge scale at a store necessarily, but we need to have maintain availability in a lot of cases. So we're looking at being able to run multiple instances within a store environment. And also provide a wide variety of platform capabilities for our software developers that are going to be deploying their services out. They need to know how well their services are running, are they operating well, are they still alive? So we got log and telemetry collection for that. And also things like service mesh, where we can do registry lookups and understand if we need to do a circuit break type capability down there, how that needs to operate. And so service mesh is a great way of operating from that perspective.
So Jeff, about how many services do you think we'll be running?
There are dozens and dozens of services that make up the point of sale capability that we need to run at the store. Everything from the cart capabilities to looking up items to calculating taxes to the checkout experience to there's, I don't know how many are there, about a dozen different ways to pay for something at a Walmart store. I guarantee you there's ways of paying for things that you've never heard of. And things that I've learned in the last year are pretty crazy. So we looked at building out a cloud-like environment in our stores. Now, we don't have a whole lot of hardware to run this on, but we found Kubernetes to be an actually pretty decent approximation of what a cloud might look like if it were running in that. Because I can get isolation of my services. I can have these pods that run my service, and those are very nicely separated at the image level. I could get multiple instances of them as well. I can load balance across them with the service layer. If you're familiar with Kubernetes terminology, the service layer handles that for me. And I got a lot of routing and other type capabilities at the network of the ingress layer that I can do as well. So we think this is going to be a pretty decent, do a pretty decent job for us. We've been doing a little bit of R&D on it, and it looks really promising down inside that environment.
So great, you've now taken care of challenge number one. Now what are we going to do about all the data?
Yeah, data is a really big problem. The data is an interesting thing for us. We looked at multiple options on how we wanted to handle data. In particular, we're looking at like, do we write additional services that move the services that were in the cloud and move them down to the store, and that wasn't going to work right. We thought about lighter weight wrapper services, modifying our services to read the data directly from the database at a store, or try to cache it locally and trying to figure out how that would work. So kind of looking at like, if you were to look at like wrapper services, what we would do is we have this data that sits out in the cloud, and we move it down to copy it over to the store, and then write a wrapper service that sits around it and serves it up. And that works out pretty well because I don't need to modify my original service, and using a service mesh, I can just route it directly down to the local service, and if it circuit breaks at that bus, I can always route it back out to the cloud. Seems like a really good option. We thought about that, but the problem was we have a lot of data and a whole lot of services to go right, and not so big a team to go do all that work at this point. And so we looked at that and was like, that's awfully difficult. And splitting the data is actually a really, really hard problem. Trying to figure out like, actually doing it and splitting it all up and getting it out to 6,000 locations across the entire country is a pretty daunting task. Just moving the services was a hard one enough, so moving all the data was even harder. So we looked at kind of an option two was modify the services again, or split the data out, so we're still doing that, and then just copy down the store, drop it into a database, and have the service read it. And if you subscribe to things like dependency injection, this might be a pretty decent option because I can configure a different data provider. Instead of making a service call, I can just make a database call. Not a bad option. I still have to move all my data down and then insert it to the database and make sure it's updated. So also another complex type operations. So then we looked at caching the data. And this has got a little interesting. This is a little bit different. So we still let the service talk to the cloud. And so, well, what happens next is kind of interesting. We layer in a network proxy. So if you're familiar with proxy caching, like CDNs and Akamai, maybe even I think CloudFront from Amazon, similar type capability. Squid proxy is one as well. And we could set that between our service and our cloud, and data would naturally kind of get cached in between these things. And I don't have to make changes to anything, and this thing will return data. So as soon as it caches that data from that first network call, the second network call that goes out for that data would just like zip right back. And so I've got my latency issues start to look a whole lot better. I take one hit versus thousands. And if my network goes off, I've got a nice cached piece of data sitting in my stores. And the best part about it is it's a very generic way to go solve that problem. I'm not writing a whole bunch of extra services. I don't have to split the data out. It kind of naturally happens from the original service providers back in the cloud. So we really like this option. We're really investing a lot of time looking at this and trying to figure out what that's going to look like. So Pam, I've got services and I've got data location. What about scaled deployments? What's that look like?
Right, so as you can see on the map there, we've got a few locations in the U.S., about 6,000 plus, and if I look worldwide, I've got about 10,000. So you think about the problem of scaling across that many sites and how we roll this out with dozens of services for each different site. It gets a little complex and a little fun because you start looking into network availability and then things like failures. So what if a store's offline or doesn't have power, stuff like that. And
so how many services is that? What's the math on that? Dozens of services, 6,000 sites. Those are all complex operations. Those aren't just like data points.
It's a whole bunch.
There's a lot. There's a lot. So what other issues do you have?
I think we covered limited network availability, and I think the one that we haven't covered yet is we're expected to do this with no downtime. So we don't want to impact anybody who is standing at one of our cash registers or using one of our scan and go devices, self-checkouts, and trying to check out of the store, because that's the most frustrating thing we can do for a customer, is not let them leave with the stuff that they want to buy. So what we did is we looked around and we found some tools for orchestration. We're starting to use Concord and Ansible and use that to do our deployments. We've had very good success in that space. And then we also have to think about order of install. So the dependencies between installs, if one service requires something else to be in place before it will work properly, we have to manage that, and we use the orchestration tool to help us with that. Next one. And then we also have to think about the availability of that service. So how do we keep it always available to the customer? And then that leads us into the concept of draining services. So maybe I have to take my workload and drain it from that service so that I can deploy the new service. And this is one space where Kubernetes actually helps us because we've got the multiple instances in the store.
That could be a pretty complex process, because if I've got somebody standing at a cash register and we've started a checkout experience where you're scanning, you've got 100 items in your grocery cart and you're scanning them through. What's that look like to go drain the services and try to flip things across and over? Because I've got state that I'm maintaining. So there's some interesting problems there for us to go solve as far as updating services and moving versions through. So you got a tough job.
It does get tough every once in a while. So we have across our network, I kind of alluded to this a little bit earlier, but we've got some pretty complex flows that come across our network. So a lot of our payment authorizations come across the network back up from the stores into our authorizer. We bring sales data and inventory movement back up from the stores to the home office. And then we also send packages and all different kinds of software down to our stores and different communications that we want the stores to get. So I have to really figure out how I'm going to manage that, because there is a limited bandwidth there. And if I'm not careful, I can get into a network brownout situation and really cause some impact to my customers and not be able to take payments and stuff like that.
So what is a network brownout? What is that?
I would equate it to a traffic jam.
A traffic jam, yeah. So what that looks like is, while we're trying to do deployments, and if you ever work with Kubernetes and Docker images and so forth, those can get pretty big. And as we start to migrate those things down to the store, we have to be real careful about how quickly we move everything, because we can clog up the network on the way down so that business data is not able to make it back out. So business operations is really important. And again, we operate stores all over the country and actually all over the world. And certain areas of the country just don't have the kind of bandwidth needs that the store really wants to get. And so we have a lot of different operating environments on network, and so those can be really challenging. We also have the ability to fail over to satellite, which is really limiting. The latency on that is massive. I think it's about 3-second latency.
It's
so
terrible.
We can do things like just credit card transactions. That's about it. So we have to be able to stop what we're doing so we don't clog the satellite for sure. So yeah.
Right. So we'll be looking at throttling and handling that through our tools that we're going to use for the orchestration and deployment of our applications so that we're not impacting that. Quality of service is another concept in this space, and we're still kind of digging into this one, but how do I prioritize my different load that's going through my network when it's going to clusters and not just a single IP address? Because most of it is done, most of your prioritization is done on an IP address.
Right, yeah, and with as we move toward a clustered type environment, we have a whole bunch of things we're running on all the same IPs within that space. And so being able to differentiate between the traffic between all those services is actually really difficult, and we're not quite sure how we're going to handle that one. So there's some interesting problems still to go solve. What about availability?
Oh, yeah, availability is an interesting one. So sometimes when we try to deploy stuff out to the store, something's not just right on the clusters or controllers and stuff in the store. So we'll get a failed deployment, and then we have to go be able to handle that. So we're looking at, can we automate that process so that it will automatically retry? And how do we know when we should retry? Is it an automatic retry, or could I impact the site if I did that?
So are the stores always, network always up on a store?
Oh, no. A lot of times, somebody will cut a fiber while they're building around our store or something, and we've got absolutely no network.
Yeah, that's one of the problems we also face is we see when a Walmart store will pop up, you'll see a lot of development happen around it. And that's when we seem to see a lot more network failures, is when people are digging holes, right? So they cut our fiber lines.
Yep.
And while we can sort of go up through satellite, we actually consider that store offline at that point. And so Pam's deployment team now has to, what they do, it's like, so if the store, you can't transfer something, you got to keep track of those and which ones are on and off and which ones are completed. So some difficult problems to solve there.
That wouldn't be too hard if we only had 5 or 10 stores.
Yeah.
With 6,000, it gets a little complex, so we build in some reporting and some monitoring of some ticket queues and some stuff like that so that we can actually see what stores got which software and then go address after they're back up online. And then worst case scenario, what happens if I have to roll this software back? I don't want to ever have a point where I'm going to impact my customer, but I've got some broken software out there and I need to take that out of production. So again, this is another space where Kubernetes will help us because we'll have copies of the previous versions and we can roll those back out there.
Yeah. So kind of pulling it all together, kind of a very high level, this is what our diagram kind of currently looks like. Kind of our release deployment team is using Concord as an orchestrator, and what that's doing, it's identifying all the stores in whatever region. Sometimes we just deploy just to one region, not to the entire United States, on which stores actually need a certain package to be deployed to it, and then fires off these, I think those are Ansible copybooks that go out and like blah, 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 and start doing all the work to do the deployments, deploy all my services into the store cloud, which then can go back and communicate back with my main cloud to get its data.
So how do we make all this happen? Well, we do it because we bring together world-class technologists and we use the best technology that we can find in a situation with lots of automation, and we give each one of our developers the autonomy and the power to go look at the decisions that are best for the project that they're working on and to make it better.
Yeah, I think that's a really, really important one, Pam, is building out a really diverse culture of developers and given that ability for them to make the decisions that they need to make to go be successful within their own environment. And I think that's really what we're all here for today, is to understand that and do lots of automation. So. I think we're out of time, Pam, for the next presentation, but we'll be available for questions anytime. So we'll be here all afternoon. Thank you, guys.
Thank you.